Hey everyone, we're up to 18H now, which is families of functions and transformations. We've done families of functions before for the other topics or chapters that we've been through. Hopefully we can remember that with a family of functions, you might be given a rule and it's got some like extra unknown letter in it. So if we use this one as an example, we can see that we're familiar with most of this except for the b that's there. We don't know what number the b is supposed to be. So this whole rule here would represent all the functions or all the graphs that might look like this, but b is changing. Okay, so it represents a whole lot of functions rather than just a single one. Okay, so that's what's going to happen in a lot of the questions that you come across in the book when you try to do them a little bit later. Okay, cool. So let's take a better look at this question. So for the family of functions with this rule here, and it's telling us that b has to be greater than 2, it's asked us to find the derivative. Now it doesn't matter that b is in there, we just treat b as a normal number. Now we know that we might have to at the moment expand that out to be able to find the derivative, but we have our CAS. Let's just do a little bit of CAS practice. So in order to differentiate this using our CAS, we have to click the following button. So you go to menu, then you go over to calculus, and then you'd be clicking, what is it, derivative. So I want you guys to do that right now. Once you've entered that in, press enter, and it should give you this as your answer. There we go. So rather than doing it by hand, we've used our CAS, we've saved a little bit of time, which will help you out when we do our tech tests and exams as well. Alright, now the next one, it's asked us to find the coordinates of the stationary points. Now hopefully if we remember, stationary point, that means that the gradient is 0. So we're going to have to use our gradient function, or derivative, same thing, to find where the gradient is 0. So, here's our rule for the gradient. We want the gradient to be 0. Now you could do this by hand, but let's keep using our CAS. So we want to solve for x. We want the x value where the gradient is 0. So let's use our solve function, and we want to solve for x. So we put that comma x at the end there. Now if you press enter on your CAS for that one, it should give you a couple of answers. One of them is going to be x equals 2, and the other one should be this. Cool, so we've found those two x values there. That's where the gradient is 0, or the stationary points, but we want to find the coordinates, so we need to find the y values as well. Okay, so if we're trying to find y values, we're not going to be using the gradient function because that compares the gradient to x. We want to use our original function because that compares y to x. We want to find those y values. Okay, so if we did f of 2, and if we did f of this, that's going to tell us what our y values are. So I'm going to really quickly do that on my calculator. A quick way to do it would be defining f and then writing f of 2 in and this one in as well. So if you do that, you're going to end up getting that f of 2 is 0, and this one here ends up being this, which is a little bit more complicated. 27. Okay, now it's asked to find the coordinates. Now these two things here, they show the coordinates, but it's asked us to find the coordinates. Let's show them as coordinates just to make sure that we're right. So therefore the stationary points are at x is 2, y is 0. And where x is that, y is this. Okay, there's the 2. Now as we can see, this stationary point here doesn't really have anything to do with b, it's just always going to be at 2 and 0. But this one here, it depends on the value of b. Okay, but whatever the value of b is, that's where it's going to be. You just need to substitute b in. Let's move to the next bit. So show that there is always a maximum at x equals 2. Okay, we already worked out before that there's a stationary point at x equals 2, but it's saying that it's always a maximum. Now, I've just drawn this graph here to hopefully show it a little bit better, but here's the rule. If we look at this rule here, we can hopefully see that this part here tells us that there is a turning point on the x-axis at x equals 2, which is here. And this bit here tells us that there is an x-intercept at b, which would be here. Now I don't know exactly where b is. B, it could be here, 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 all the way along there. But they did tell us at the start that b has to be greater than 2. So 2's right here. B can't be over this side. So it has to have your maximum there and then go up again. So the reason I know that it's going to be a maximum there and never change to a minimum is this is like a positive graph. So the tail of it's going to be pointing upwards. Okay, now if we move this further over to here, our x-intercept, it's still going to, I might use a different color. It's still going to mean we have to point it upwards like that. Even if it's over here, it still means it's going to have to point upwards. So this is never moving. Okay, never moving at all. So what I'd kind of do here, you probably could show it with maths, but I'm just going to write a sentence to explain it instead. I'd write something like, therefore, always a max at x equals 2. Because b must be greater than 2, which means that the graph will always maintain the same shape. Now the graph that I drew here sort of explains it a little bit as well. So if you kind of had both of these things here, you'd be fine. You'd get your full marks. And let's move to the last bit of this question here, D. Find the value of b if the other stationary point occurs at x equals 4. So we don't know exactly where that other stationary point is. We've got the coordinates of it there, but we don't know what b is. We're finding the value of b. Okay, now at a stationary point, the gradient's going to be 0, and it's telling us that the gradient's going to be 0 where x is 4. So I think we're going to be able to use the derivative that we found a little bit earlier. Okay, so I'm just going to write it down to set us up. Okay, so the stationary point occurs, so that means the gradient 0, so this is 0, where x is 4. So let's make x 4. So hopefully we can see now that the only unknown in here is b. So we're going to be able to solve for b. And if you solve it, I'm just going to do it quickly here so you don't have to keep watching. B should be equal to 5. Right, so let's move on to the next one. So the title spoke about transformations as well, which is what we're going to have a little bit of a look at here. Right, so it says the graph of the function, it gives us a rule here, so x to the power of 4 minus 12x cubed, is translated a units in the positive direction of the x-axis and b units in the positive direction of the y-axis. A and b are both positive numbers. So before we have a look at a, let's just kind of decipher what this actually means. So we've got this graph here. It might look like whatever. I don't know if we don't really need to draw it. All we really need to know is that whatever the graph looks like, it's telling us we're going a units in the positive direction of the x-axis. So that means it's shifting the whole thing over a units. We don't know how many that is. It could be 1, it could be 2, it could be 100, whatever. We just know that it's moving to the right a certain amount. And the same thing with this bit here. So it says it's moving b units in the positive direction of the y-axis. So it's moving up a certain amount as well. We don't know what that amount is just yet. Alright, so now let's have a look at A. Find the coordinates of the stationary points of f of x before transformation. Okay, so it says before transformation, so we're not really worrying about A or B just yet. We just want to find the stationary points of our rule here. Now, stationary point, I've said this a lot of times. At a stationary point, the gradient is 0. This rule here doesn't tell us much about the gradient, but if we differentiate, we will have a rule that tells us about the gradient. So I'm going to put the derivative here, so you guys can hopefully do this reasonably quickly now. There you go, we've got our derivative. And we want to know the values of x where the gradient is 0. So the gradient, that's this bit there, make that 0. And we now can hopefully solve for x. Now you can do this with your CAS, you can do it by hand as well if you like. I'm just going to do it by hand now because I think it'll be quicker than grabbing my calculator. Alright, so we've got x equals 0 and we have x equals 9. Cool, so we've got our x values, but we need our y values as well because it's asked for the coordinates. So we need f of 0, which is going to end up being, if I look at the rule, if you make all the x's 0, it's going to be 0. And f of 9, what's that going to give us? If you sub it in, it ends up being a pretty big number. I'm not going to do it right here. You guys can do it yourself or put it in your calculator. It's going to be negative 2,187. So that one gives that coordinate, and that one gives this coordinate. Cool, so we have our coordinates of stationary points. Now B, after transformation. So remember, we were moving A units to the right and B units up. What are the coordinates of the stationary points of the image? Now, whenever you see the word image, that means like the rule or the graph or any points on the line or the curve after it's been translated. Okay, so image is always after translation or transformation, sorry. Alright, so our old stationary points were these, weren't they? We just found them out. Now we're going up, we're going right, A units, and we're going up, B units. Okay, so let's just focus on this one first. So this one, we're starting at 0, 0. If we go right A units, it's going to be 0, 0 plus A. Oops, I don't need that bracket there. Because the A is impacting the x coordinate. But the y has to go up, doesn't it? It has to go up b, so it's going to be 0 plus b. Now, these zeros we don't really need, do we? So that coordinate is actually going to be at a and b. So let's move from there to there after those transformations. But the same sort of thing is going to happen over here as well. So that x coordinate, it's going to be moving across a, so a more, 9 plus a. And this y coordinate is going to be going up b. We don't know how far b is, but that's okay. It's just going to look like that. So we're done. Those there are the new coordinates of the turning points, depending on what a and b are, because we were never told.